Anybody want me to revise derivative of inverses? No? Okay. What do we have? So, from the formula sheet, we realized last week, if we had inverse sine of f of x, the derivative, well, let's take a screenshot of that again. We realized that if we had the derivative of an inverse, it would be the derivative of the inside over square root 1 minus the inside squared. For inverse cos, it's exactly the same, except it's a negative. And then for an inverse tan, it must be the inverse of the inside over 1 plus the inside squared without the square root. Same rules still applied. We did, I remember, I think Stefan did this last one. I remember we did even some of these application case questions, which is really good. And pretty much we're up to the integration. So in your formula sheet, this side here is for differentiation, this side is for integration. But if you look at it, I mean, it's exactly the same. So look at this, y equals, and then derivative is this. Here, it just says the integral of the right-hand side, integral, is equal to inverse sine f of x on a. The only difference is the fact that you've got a here, but we're still going to do our things with ones. I believe it's a better version instead of the a. So, but essentially it's exactly the same, except here it's a squared, here it just says 1. But we'll see how we go. We'll try to use this if we can until we get stuck. You can see there isn't one for inverse cos, so there's just inverse sine, inverse tan. Reason being, inverse cos is exactly the same as inverse sine, except it has a negative. So they didn't bother writing it, I guess. But you've got it here. So exactly the same, except this will just be a negative inverse cos. Okay, so let's start some of our integration questions here. I might start a new booklet again. Actually, it's just a bit easier to work with. Take a photo of this, and then here we go. Okay. Find the following indefinite integrals. Okay. I, integral of 1 on 16 plus x squared dx. Can anyone tell me if this is going to be an inverse sine, inverse cos, or inverse tan?
Sine.
It's not.
Right.
Sine, just yes, it is.
Tan. No.
Sine needs to have a negative and needs to have a square root. Cool. So this one is going to be an inverse tan. Now, I just realized I gave you the wrong one here. It might be a bit easier to start with this one. So once you realize it's an inverse tan, the formula is just this. So if the inside, the derivative of x is 1, which it is, it's just horrible. Look, I'm going to show it the way I would personally do it. What you need to know, the most important thing of this is the fact that is if it's inverse tan, it's 1 on a. So 1 on 4, right? A squared, 4 squared would have given you 16. So 1 on 4, inverse tan, f of x, which is this guy here, squared. So that would be x squared on 4. on A plus C. Let's look at that again. 1 on A squared, 16, 1 on A. Do we get that? And then this says f of x, so something squared goes on top, something squared goes on top. And then still A, this is still A, plus C. Any questions about that? No? All right, let's start the next one. Double I. What's that? What's double I going to be?
That one's sine.
That one's definitely an inverse sine. So 1 on square root 9 minus x squared. Do you want to just tell me the answer as well?
Would it be sine, an inverse sine?
F of x, which is this guy here.
Where is it? 9, wait.
No.
X.
Yep, x on.
X on.
This
9.
says, nope, a
On
squared was 9. So a becomes?
3.
Beautiful. Plus c. So a squared is 9, and this must be the square root of 9, which is 3. A squared was 16 for here, and then we should choose a, it becomes 4. Okay, that was good. Reason why I say I don't like these formulas, x must, this bit here should actually just be x. Now, if it was 4x squared, there's going to be some problems, because you might not have, like, no, we'll just come to it. But anyways, once we come to it, I'll tell you what I would like you to see it. For now, I think it's easier just to see it the way we're doing it, but eventually it's going to be done a little bit more, just a little bit differently. But right now it's good, because these are easy. Triple I, integral of x squared plus 49 to the power of -1. Well, we don't use -1. We're going to make it x squared plus 49 dx. And then, of course, this is again an inverse tan. So the answer just becomes 1 over 7 inverse tan x on 7 plus c. So that there isn't really much work that's required for inverse integration. It's just knowing which one it is and if it's in the right format. Okay, and IV. IV is the problem one that I've been talking about. So it says to the power of -12. We can't choose -12. We'll make it a positive half in the bottom, and then positive half just means square root, right? So really you end up with this. Now, anyone tell me what this one's going to be? Is this an inverse sine, inverse cos, or inverse tan?
Sine.
It is inverse sine, thank you. The problem with these formulas that they've given you in your formula sheet is that it specifically says if this is f of x, then the top needs to be the derivative of f of x. And if that's the case, then it becomes this exactly, right? Now, look at this one. Well, f of x would have technically been what? 4x, so it was squared to get you 16x squared. The derivative of 4x is not 4, it's not 1, right? It's not 1, it's 4. So there's a problem. I can't just straight away say, oh, that's the answer, inverse sine of 4x on 5. There's going to be a little bit more work that's required, especially for that 4x. Now, I can tell you how to use it, but I think I would rather tell you guys to do this. Make this into an x squared. So it will look like this. Square root, integral, 1 on, square root factorize 16 out. You get 16, 25 on 16, minus x squared. Right? You guys see what I've just done now? Factorize 16 out. Then, what's the square root of 16? Well, that just becomes a quarter. And then I'm left with what? Square root of 25 on 16 minus x squared. I'll just stop there for a second. Anyone not know what I've done with each line? Anyone confused? Okay. Okay, then a quarter, I can take that to the outside, so that becomes a quarter. And then I'm left with 1 on square root 25 on 16 minus x squared dx. Now in this case, can you see that the derivative of your function here, which would just be x, the derivative of x is going to give you 1. So it's back to the formula that I like, which is actually this. So the answer now is a quarter, and then once you realize this is an inverse sine x on a being 5 on 4. So the answer we're looking for, 4x on 5 plus c. Now please go through that slowly. Tell me which line you would like me to repeat. The most important line was just here at the beginning, which is factorizing your 16 out. We want only a singular x, a monic x squared. It cannot be a non-monic. Not yet. Until I can see you guys getting comfortable with this, that's when I'll teach you some other tips and tricks. But right now, it's going to be done this way. As though we all know, you're not going to get anything wrong. Let's recap. 16x squared was annoying. So these ones here, nice and easy, had no problems, had no problems, had no problems. I just did them normally. I followed the formula. These ones here, 16, I can't exactly follow the formula. So what I've got to do, I've got to factorize it out, and I'm left with 25 on 16 minus x squared. Square root of 16 is 4 in the denominator, so I left it there. And then I still got square root attached to all of this. Then I took a quarter out, and then I'm left with this, which now I know it is an inverse sine. So my answer is a quarter inverse sine x on a being 5 on 4, and then just multiply it up, 4x on 5. Okay. There's no questions for that. I'm going to keep moving. Please don't be shy. Just let me know if you're stuck with something. Because literally there's 4 more questions and we're done. There's not much. You can see how compact Year 12 syllabus is compared to the Year 11 syllabus. Okay. With limits, well, I'm going to pick someone to do this with me. Let's start with you, Stefan, I think. We're going to do I together.
All right.
Let me know when are you ready?
Yeah.
Okay, here we go. Square root 1 minus x squared. Obviously, what do you think? Inverse sine, inverse cos, or inverse tan? What does an inverse tan have a square root?
It's got an inverse. It's inverse sine.
Yeah. Does an inverse tan have a square root?
No.
No. So straight away you know it's not inverse tan. And if it was a negative here, it would be inverse cos. There's no negative. Yeah. It's inverse sine. Cool. So now you know it's an inverse sine. Yep. And x on a. So what are you going to say to me? X on a.
F x is 1.
X. Yeah. X. What? So inverse.
Oh, x.
So f of x is x on
1.
a. 1.
Plus c.
Then, but there is no plus c. Why?
Oh, because it's limits.
We've got limits, so you're going to sub in 1 and 0.
0.
So the answer becomes inverse sine of 1 minus inverse sine of
0.
Okay, plug that into your calculator. Inverse sine of 1 gets me 90 degrees. Don't forget, that's not 90, as in 90. It's actually 90 degrees minus inverse sine of 0, which is 0. So the answer becomes pi on 2.
Sam, can you just go up for a second so I could see the formulas?
See the formulas, yep.
Yeah, thanks.
You know which formulas I would like you to write here? So now that I think you guys are getting it, these are not the two formulas that I would like you guys to use. Our formulas are going to be more like this. Yeah, I'll just write them up. I'll just write them. So these are our two versions. If it's 1 on square root 1 minus x squared, I just need you to memorize this. It's inverse sine of x plus c, if you want to write that. And then integral 1 on 1 plus x squared dx is inverse tan x. So I'm more interested in knowing that you know it for 1. If anything, the only other version that I don't mind writing is this, and then going, this is over a, then this would be over a, and this is 1 on a plus c. So you could write that one. 1 on a squared plus x squared is 1 on a inverse tan x on a. 1 on square root a squared minus x squared is inverse sine x on a. I don't want to write f of x. Okay? And then let me just go up again. So that's a better version instead of all these f dashes and stuff like that. We can avoid doing everything that they're asking us as long as this x can be a monic, which is the way I want it done. Okay, any questions? Novak, you wrote this down? No?
Yep, thanks.
Okay. Yeah, cool. I, any questions for I? Anybody? All right, double I. From -1 to 0, 1 on square root 4, 1 on square root 4 minus x squared dx. Okay. After Stefan, let's go with Azra. Let me know when you're ready.
Yeah.
Cool. What do you want it to be? Inverse sine, inverse cos, or inverse tan?
The inverse sine.
It is inverse sine. And again, we can just follow the little formula I just created up here. So that would be inverse sine x on.
2.
And then what's my next line?
That would be sine inverse 0 on 2 minus sine inverse -1 on 2.
Okay, let's make something clear. We've been talking about on Thursday, we can't inverse negatives. That is true. The only reason why we can't inverse negatives in Thursday's class is because we need to find more solutions. Like we've got all stations to central to do, right? We've still got this stuff to do. So we haven't been inversing because we need to find like where sine is negative, which would be tan and cos, let's say. But if you're just trying to find a solution, you can just inverse a negative. If you don't need more solutions, if you're not interested in the second one or the third one or anything like that, then you can inverse a negative. So that stuff is more for the solving of year 11 trig. In year 12 trig, when you're doing things like this, you don't care about all stations to central. So please don't get that confused. Inverse sine of 0 is 0. Minus inverse sine of negative is negative 30 degrees. So what's your answer, Azra?
Be pi on 6.
Good job. Thank you. Triple I. Who's next? Triple I. Ben, you're going to be next. Triple I.
Hello.
Is half 1 plus 4x squared. 1 on 1 plus 4x squared dx. Okay, let me know. All copied down? Double I?
Oh, yeah. I
Okay.
have.
This one,
At the 10.
that is an inverse tan. Remember, let me write the formula just one more time here. A squared plus x squared becomes 1 on A inverse tan x on A. X must be monic.
Mm-hmm.
Cool? All right.
Yep.
Tell me.
So we factorize out the 4. So it'll be 4, 1, 4 plus x squared.
Beautiful. You can just take a quarter out. There is no square root, so that can just go into the outside. And then you're left with a half, 0, 1 on A squared plus x squared. Beautiful work. Okay, and then next line becomes a quarter times 1 on A. What's A this time?
A quarter?
No.
Oh, wait, a 16th, right? Is it? Wait,
No.
wait.
A squared is equal to a quarter right now.
Yeah.
A would equal to
A half.
a half. So 1 on A. If A is a half, this becomes 1 on a half.
Which is 2.
Yeah, which is 2. Good. Inverse tan x on a half.
Which is 2x.
And then your limits. I'll just wait, see if anyone's got any questions for us while we're here. Does everybody get the fact that we said a squared is a quarter and then therefore a became a half and not a quarter here? And again, I wrote this quarter in the outside, and then this business is our 1 on A. 1 on A, inverse tan x on A. Okay, if we've got no questions, 1 on a half is 2. 2 times a quarter is a half. And then I just leave it in the outside because it doesn't really make an impact to your limits. Okay, half, and then what are you going to write?
Inverse tan. Wait, yeah, inverse tan 1. Is that right? Yeah. Minus inverse tan 0.
Okay, inverse tan of 1 is pi on 4, 45 degrees. Inverse tan of 0 should give you 0. So the answer is pi on 8. Good stuff.
Yeah.
And last one, who's next? Next is Greg. Greg, last one. 5 on 6. Yeah.
Yep. It's sine.
It is inverse sine.
And so what you do is you first factorize the 9 out. So you would get 1 on 9 brackets 25 on 9 minus x squared. And then you take the 9 out, and then you get 1/3, which you can just take out. Which gives you with 25 on 9 on x squared. And now you just
Hold on. I'll just rewrite the formula in case we need it. Integral 1 on square root a squared minus x squared is just inverse sine x on a. Okay, 1 on 3.
So it's 1 on 3 inverse sine x is just x at this point. and then it's over 5 on 3.
Over 5 on 3 on 8.
And then that's 3x on 5.
That's it.
And then you use the limits.
5 on 6 on 5 on 3. I can't be bothered changing it, just leave it like that. And then minus inverse sine of 0.
Yeah.
Inverse sine of 0 should give you 0, and then you're just doing this 5 on 6 and 5 on 3, which, let's see what it becomes. Divided by 5 on 3.
It's 5 on 6. Because, I mean 3 5 on 6. 3 5 on,
no,
yeah. Well, 3.
It becomes
3
It becomes
on 5.
3 on 6. I think it becomes a half.
Yeah.
Because the 3 would go on the top.
Yeah.
On 30, pretty much. That'd be nice. 1/3 times pi on 6, which becomes pi on 18. Cool. Good work. All right. Let's. Any questions, you guys? Really? Okay. Looks like we're done. Well, we don't need that because I didn't do anything to that, but we will need this. So save this. Cool. Okay. Well, you have now officially finished off the Extension 1 and Advanced course, pretty much all of calculus for Advanced and Extension 1, which is great. Now it's time to start Extension 2 integration. Extension 2 integration. All right. The first bit is going to be good revision. It's just substitution, which is what we did in a few weeks back now in Extension 1. After substitution, it's more substitution and then partial fractions. All right, cool. Something new. All right, let's revisit this. Whose turn is it next? Mariette, your turn.
Okay.
Oh, the answers are there. I'll just be guiding you through it, and then you'll let me know if there's any steps that are confusing you or anything like that. The problem is you're in Extension 2 now, and you have to work out the substitution yourself. So in 3 unit, your substitutions will be given. In 4 unit, your substitutions will not be given. So you have to realize what your substitution is. Now, now observe the fact that we let u become x cubed plus 5, the bottom, right? And the only reason why we did that was because what would be the derivative of x cubed?
3x. Oh, wait. Yeah, 3x squared.
And the fact that you're going to have x squared on the top, right? Because we were writing it like this, du equals 3x squared dx. The fact that you're going to have x squared dx straight away, x squared dx, means that your substitution was correct, x cubed plus 5.
Okay.
Now, if I chose just x cubed, no problem, this becomes u, you're still going to get x squared dx, right? Oh, you'll still have a 3, sorry, but you'll still get 3x squared dx. Do you agree with that?
Yeah.
The problem is when you're going to substitute it back in, look what you're going to write. You're going to write du on square root of u plus 5. But now good luck trying to integrate u plus 5. I mean, it's possible. You're just going to bring it up, do very similar things. It's just a bit more annoying because you decided to have the plus 5 in there. Whereas if you had included plus 5 part of your u, well, what happens to plus 5 when you differentiate it anyways?
Becomes 0.
It becomes 0, so you might as well have included a part of your substitution. Cool?
Yeah.
That's going to be the logic. So the reality is you're not looking for the substitution. you're actually looking for the derivative of the substitution. So you're making sure when you're saying, okay, let's use x cubed plus 5, if you differentiate that and it gives you some of the derivative and the derivative exists there, then your substitution was correct.
Okay.
All right, and let's go. So u equals x cubed plus 5, du becomes 3x squared dx. What did we say? We said the way we were doing it, we don't like the 3, so we will be dividing by 3. And then again, what's x squared dx now? X squared dx becomes what?
U.
Du on 3. So we were writing a third on the outside and then just putting the du in the inside, correct?
Yeah. Over
And then
root of u.
and then 1 on root of u. So we pretty much are skipping this line. I'm making you guys skip a line now. We're doing it a bit faster. And then that becomes u to the power of negative half.
Yeah.
And then of course, when you integrate u to the power of negative half, you add 1 to the power and divide it by the power. Right?
Yeah.
And then when you divide by a half, it's the same as multiplying by 2. And then what must you do just before you you finish off? Because you don't have any limits, you have to substitute your x back in. So it becomes x cubed plus 5 plus c. All good?
Yep.
All right, brilliant. Next, who's next? Thule, it's you. Let me know when you're ready.
Yep.
Cool. This one here, we've got the integral of dx on 3x plus 5. Again, you can tell that there's only a 1 that exists, so that means your substitution you're going to pick is going to be 1 power higher than 1, let's say. So 1 power higher than a constant would be a linear, or x to the power of 1. So it makes sense to choose your substitution as 3x plus 5, because when you differentiate, you're going to get 3, which is easy to remove. You're just going to divide it by 3, and there it is, just dx. And then again, what does dx become now? Dx becomes du on 3, and then over
u.
u. Ready? Du on u, 1 on 3 in the outside. And then what's the integral of 1 on u? You might have just seen the answer, but
U to the negative 2.
yes, u to the power of negative. Hold on, let's do that one. That's a good question to just remind everyone what happens. Because we would have spoken about it, we would have done it, but you guys are not used to it just yet, which is fine. 1 on u du. Now, very tempting to do what we just did here, which is u to the power of negative 1 du, correct? All right, now tell me, what's my next line if I integrate this normally? You've got to add 1, which is u to the power of
0.
0 over?
0.
Over 0, and that's a problem. What the? How do I do anything over 0? You can't, and once you realize that, you realize, this has to become a log. So this is the only algebraic expression that ever becomes something other than algebra, let's say. So if you had trig, it was trig. Inverses as well, but you can realize inverses because they usually have like plus x squared and stuff, so it's a bit easier to identify. These ones here are a little bit harder. You've got to realize that if you've got the top as the derivative of the bottom, then it is log of the bottom. So log of u. So that becomes log u, and then of course, replace your u back for 3x plus 5. Any questions about that? No? You feel comfortable with that? Do you feel comfortable with, do you feel like you could have identified your substitution in the first one now and in the second one after what we've done?
Yeah, kind of.
Okay, that sounds good. Novak, your turn. Example 3. Let me know when you're ready.
Yeah, I'm here.
Okay, so x square root 1 plus x squared dx. Again, you're letting u become 1 plus x squared. Why? What's the reason?
Well, I can't see.
Can't see it down there?
No, because it's blocking the camera. Here it is.
There, okay.
So you can find du equals dx.
Yes, but du would equal to what? When you
2x.
differentiate, say again?
2x.
Dx. 2x
Yeah,
dx.
2x dx, yeah.
Yep. And why did you want that? Because the original question had
And dx.
yeah, x and a dx. So technically we would be dividing it by 2.
Yeah,
And then again, x dx gets replaced for
1/2.
du and then square root of.
I'm lost. Where we up to?
Well, we just got rid of this. We got rid of this. We're up to the square root of
So square root of u.
u, right? Because 1 plus x squared is going to become u. And
Yeah.
then u to the power of 1/2, you add 1 divided by 3/2.
Yeah, and then plus c.
Oh, I think there's a mistake there. Half u to the power of 1 plus half is 3/2 times 2/3 plus c. And then the answer should become 2/2 cancels out over 3, which I've still done. And then, do you know how to get from this to this?
No.
Okay. U is what? U is what? What is u equal to?
1 plus x squared. The other two.
How do you think now? Come on, think about it. Think of your surds. Think of your index laws. How do you move from this to this?
So isn't the square root of 1 plus x squared like 1 plus x squared to the power of 1/2?
Yes, correct. So this one here, I like it. You're going to the right direction so far. That's power of 1/2. And then, how does
And
this
then-
look to this? How is this top bit equal to this? When you almost have it. That's power of 1/2.
Yeah, and then you took it out from this real.
No?
No, I'm trying to.
Okay. X root x. Do you feel like you know that? Do you know the answer to that when you simplify it at all? Think of your index laws now. Again, you can change that to the power of 1/2 like you did. Should become x to the power
X
of
1/1/2.
Okay, 1.5. 1.5.
Oh, and the other one's just 1 plus x squared.
Yeah.
Yeah, there. Yeah.
So that's power of 1. That's power of 1/2. So that just becomes 1.5, which is 3/2.
2. Okay.
So it's important for you all to know x root x is the same as x 3/2. We just prefer to see it written this way. So that's simplified. Another one would be x to the power of 5/2, which is 2.5, right? 2.5 can be written as x squared root x. 2 plus 1/2 becomes 2.5. So they're good ones to know. All right. Anybody have any questions about what I've just said there, or anything we're doing so far? Okay, fair enough. All right, Queenie, you got a nice hard one. Let me know when you're ready.
Yep.
Okay, so you can see in this case, it does say the integral of cos x on 1 plus sine x squared. I'll go up, it's fine. Cos x on 1 plus sine x squared. Again, you're not going to say, because like, I mean, look, some people go, okay, can we say u equals cos x? Yeah, the derivative of cos, if you remember this, derivative of cos is going to become negative sine, yeah? And then you have to write dx. Do you have a sine dx? No, you've got dx on sine, and then it's squared and stuff. So was this the right substitution? Would this have ever worked?
No.
No. See, some of the other ones, there are other substitutions that would work. I haven't spoken about that, but there are others that would work. It's just trying to show you, in this case, that this specific one, you can't actually choose cos x. It has to be 1 plus sine x. And again, we're going to choose the 1 because the derivative of 1 disappears anyways. So 1 plus sine x, differentiate, du becomes cos x, derivative of sine is cos, so cos x dx. Cos x dx becomes du on u squared, bring it up, and then just integrate normally. You feel like you could do that now?
Yeah.
So would you say that all of this is okay for you? It's just this very first line?
Yep.
Okay. I might do a few more substitution-based questions. Let's see. All right. Rosemary, you're going to be lucky last, but I'm going to take it up a notch for you. Okay. All right, Rosemary, you ready?
Yeah.
All right, we're going to try to integrate this question. And you're going to tell me what you want the substitution to be. And don't overthink it by too much. Okay. Let u equal to
Um, 9 minus 4x squared.
yeah, killed it. What is the derivative of u? You're going to say du. What is the derivative of negative 4x squared?
Negative 8x.
And then again, you can see now your substitution was beautiful because you wanted x dx, and you do have x dx. You can get rid of negative 8. Done. Come here. That becomes negative 1 on 8. Integral. X dx becomes du on square root of
U.
and then negative 1 on 8, u to the power of negative half. I like to just do it in one line. And then that becomes what? U to the power of positive half, 2 over 1. So times by 2 over 1. Are you okay with me writing like that? 2 over 1?
Yeah.
Yep. And then plus c because there's no limits. And then 2 times negative an eighth is negative a quarter. Square root of what? Instead of u, what are you going to substitute back in?
9 minus 4x squared.
Done. You got yourself pretty much 2 marks. Now in extension 2 as well. Great work.
Sam, what do you do with the 2 that's in front of it?
Where?
In front of
This
the
2
U?
here?
Yeah.
Yeah, so 2 times an eighth became a quarter.
Oh, yeah, yeah.
So I just multiplied it in or out. Okay. Stefan, let's do the next one. Do you remember what the derivative of an exponential was?
Log, isn't it?
No. No. That's opposite. Opposite of a exponential, you would say is an e.
Oh,
But the
derivative
derivative
of exponential is like you just change to the top.
just change the top. No, I'm not going to give that to you. No. Derivative of an exponential is still an exponential. But if what you meant by change the top was differentiate the top and then it becomes like this, then yes, but
Yeah.
the idea is, yeah, the exponential must stay as an exponential. Whereas, you know, the 1 on x, or it becomes ln x. That's the hard one to recognize. Derivative is easy. Derivative of log is 1 on x. It's the integral of 1 on x. Realizing that is a log is going to take you guys some time. But otherwise, all the other ones like sine, what does a sine become? Stefan?
Sine.
Yeah, derivative of sine x, for example. What's that?
Cos x.
Yeah. Yes.
Yeah.
Yes.
Yes.
So exponential is the only one you got to remember. It's still an exponential. You have to multiply by the derivative of the power, if there was any. Okay. We're here. It says
Yes, we are.
ex on 1 plus ex all squared.
Yep.
What do you want your u to be?
1 plus ex.
You want it to be squared?
No.
No, because if it was squared, when you're going to differentiate it, you're going to times it by 2. Times by the multiplied by this, take away 1, multiply by the derivative of the inside, like chain rule, which is an absolute mess.
We
Good.
don't.
So du, what's a derivative of this?
Du equals 2ex.
No.
No.
Derivative of 1 is?
0.
Derivative of ex is?
Isn't it 2? E.
No, it's just e. Why did you say 2? I said 2 up here because it was e to the power of 2x.
No, because I thought the number goes up by 1.
Oh, no, not for exponentials. So exponentials have to stay the same power. Ready? Watch this. That's why y dash became e2x, and then what do you have to do? Differentiate the 2x becomes, and that's it. But these ones don't change powers. Usually your algebraic ones, like these ones here, u to the power of negative half, yes, you're adding 1 to the power.
Yeah.
But here, x is the power. So
Yeah.
you can't add 1 to x as the power. Does that make sense?
Yeah.
Let's just again say that. Here, your powers are numerical, whereas your x was in the bottom, the base. Whereas these ones, your number e like 2.71, whatever, e is at the bottom, your number's at the bottom, but your power is an actual letter, like a pronumeral. So it doesn't work the same as these traditional ways. All right. Anyway, you're doing well so far. You got your ex dx. That looks good. Do you remember what you must do with your limits? Are you allowed to just write 1 and 0 when you're doing your u? No.
You go to. Wait.
I'll tell you now. When x, these are x values. So when x equals to 1, you got to find what letter?
When x equals u equals, you sub it in.
You sub it in. Good job. And then, of course, when x equals to 0, same thing. Okay. When x equals to 1, you get 1 plus e to the power of 1, which is just 1 plus e. 1, whatever. When x is 0, what's any number to the power of 0?
0.
Nope.
1.
1. You can't make that mistake, man. 1 plus 1, 2. Okay. So this, what are you going to write? Integral sign?
Yeah.
And then what?
1 plus c and then 2.
2. And then?
Du on u squared.
Too good. Let's finish it off now. Minus 2 plus 1 is minus 1 on minus 1. 1 plus e. Do I need to substitute my x back in? No, not for your changing limits, because you've already changed your limits to use. Okay.
Yeah.
Next line. Instead of going down, I'm just going to go across a little bit. That becomes -1 on u, 1 plus e and 2. Do you agree with that, what I just did there? You'd have -1, I brought it back down, and -1, I just multiplied it by negative on the top.
Yep.
Okay, next line. Tell me what you're going to write.
-1 over 1 plus e
Beautiful. Minus.
minus -1 over 2.
And you can see there's a lot of room for mistakes here with all these negatives, so be careful. Use brackets. And then, what's your final answer? Negative, no calculator, just keep it exact. So negative is going to become what?
Plus.
Plus, so that's going to become positive half, minus.
1 over 1 plus e.
You got yourself in extension 2 now. This is going to be worth 4 marks. 1 mark for the substitution, 1 mark for the limits, 1 mark showing significant progress. So up to here, maybe integrating it, and then 1 mark for the final answer. Cool, thank you. Okay, next will be Azra. Back to you now. And just anything else that I find interesting. We're going to do these soon. Yeah. All right, EX sin X. Oh. X sin X. Use this stuff. All right, actually, Azra, you're going to do this one. It's going to be a little bit trickier, but I feel like you'll get it out. Let's have a look. Okay, so we'll start it on this page. 3 and 2, 1 plus x on square root x minus 1 dx. They've already given you the substitution though. Was it square root? Did it say square root? Yep. Okay. U equals square root of x minus 1. You ready, Azra?
Yep.
X equals 3, x equals 2. I'll just finish these ones off real quick. When x equals 3, 3 take away 1 is root 2. When x equals 2, 2 minus 1 equals 1. Those are our new limits. All right. What are you going to do?
Would you find du?
Yep, you're going to find du. All right, go tell me.
Would you first change it to x minus 1 to the power of half?
Yep, and then you're going to get this. Is that right?
Yep. Yep.
Okay. That's annoying, isn't it?
Mm-hmm.
Good. So keep that in mind. Every time you're going to see a square root substitution, and you get up to this stage, you're like, whoa, that's really annoying. I don't remember doing it that hard. So get rid of it. Get rid of that. Tell me something more unique that you can do to this to make it a little bit more easier for you to differentiate. A unique concept, something that you did when you yeah, something that you did that when you told Ben your answer. You squared both sides, right? And what happens all of a sudden, it's just a lot easier to differentiate this guy and this guy this way than it was with this initial case.
Yep.
It's annoying because you're going to have, you know, squares and roots, and then you want to substitute that back in, and there's, it's just a big mess. So squaring both sides, you'll get this result. Then, what's the derivative of u squared now?
2u.
2u du, and then derivative of x is just dx. Now, this came to one of those problems that we faced when we did substitution as well. We realized, great, this is going to go, but I've still got an x on the top. I can't have an x on the top, so what did we say we can do? What does x equal to? What does x equal to?
X would equal to u squared plus 1.
Yeah, right? So all of a sudden, I had a problem. I've still got this x when I'm going to substitute it in my u's, but I can actually replace x for u squared plus 1. So it's not that much of a problem. So next line, what does your integral become? Your integral becomes root 2 to 1. 1 plus x. What does x equal to? U squared plus 1. And then dx. What does dx equal to?
2u du.
Yeah, 2u du on square root of x minus 1, which is just u. Does anyone have any questions for us at this stage?
Sam, could you just do a quick recap from the top?
Yep.
Thanks.
U
Yeah.
equals square root of x minus 1, so therefore we squared both sides and we ended up with this result.
Okay.
Then we decided to differentiate this. Derivative of u squared is 2u du. Derivative of x would be just 1 dx.
Yeah.
Now, of course, you know, we would have loved to have x dx or 1 plus x dx, and that would have been an easy substitution.
Yeah.
It wasn't the case. So what we needed to do is dx can eliminate for 2u du. There it is. That's great. Tick. Done. Root x minus 1, square root x minus 1 also becomes u. There it is. Gone. Then I've still got this 1 plus x. I can't write 1 plus x here. I'm not allowed to write 1 plus x when I've written u's and du's and stuff. That's just not allowed at all, ever, to use two different letters.
Yeah.
So the fact that it's not allowed, I can still write 1. 1's not an issue. But this x, I had to change it to make x in terms of u. So from here, u squared equals x minus 1. I just plus the 1 over, and I get x equals u squared plus 1.
Plus 1. Okay.
And that becomes u squared plus 1.
Okay. Got it.
That's it.
Yeah.
Now it's just a matter of finishing it all off. All right, Azra, you're good to continue?
Yeah.
What would be your next line?
Would you first simplify the top?
Are you going to expand?
Would you simplify inside the brackets and then expand?
I wouldn't expand. Can you see something else? I don't want to expand. What can you see if I don't want to expand this?
Do you like cancel out?
Yeah, because it's all multiplied, right?
Yeah.
That's multiplied, that's multiplied, that's multiplied, that's all multiplied. So why don't I just get rid of this guy and get rid of this guy?
Mm-hmm.
And if there's a 2 by itself that's multiplied, I can just take the 2 into the outside, so I don't have to even stress about it.
Yep.
And then all you're doing, you're just integrating this. 2 plus u squared. It's basic integrations. What's the integral of 2?
2x on
2
1, which would be 2x.
2u.
Or 2u, sorry.
Yeah. On 1, which is nothing. Yep. And then u squared.
U cubed on 3.
And then root
Plus
2. No, root 2, 1. No plus c, there's limits.
Yep.
All right, so how many marks are you up to? Let me see. That would be 1 mark. That would be 1 mark. we are pretty much around two marks at this point in time. Maybe you'll get a 3rd mark for integrating here, but I think it's only still going to be 2 marks because I can see what they want the answer to be with the root. So at this level of math, we've got to use our calculators less, like less decimals and more exact values. So you're going to substitute your root 2 in, and it's going to look like this. Root 2 cubed. Root 2 cubed is the same as me saying 2 to the power of 3 over 2, right? Ezra, do you agree with that?
Yeah.
So that's power of 3, that's power of a half. Okay, over 3 minus 2 plus a 3rd. So that's my first bracket minus my second bracket. All of that with big brackets multiplied by 2. Okay. Now, do you remember what I just did this with Novak? I said x to the power of 3 over 2 can be written like as what? What can x to the power of 3 over 2 be written as?
X root x.
Yeah, x root x. So this becomes, we'll just leave this for a second. This becomes 2 root 2 as well. Over 3 minus 2 plus a 3rd is 2 and a 3rd. So what's that? 2 and a 3rd is 6, 7 over 3. So minus 7 on 3. And then 2 root 2 plus a 3rd, 2 root 2, 6. 6 plus 2 is 8. Okay, 8 root 2 on 3 minus 7. Almost there. Can you see how most of this is actually algebra than it is integration? There you go. Okay, I times it by 3, made a common denominator, and then multiplied my 2 in. Any questions, Ezra, from you?
No.
All right, thank you. Anybody else? Just let me zoom out a little bit. If you want to see the whole question again. So that would be worth 4 marks, but this time they won't give you your 3rd mark until this line here, and then 4th mark here. Okay. Any questions? No? Everyone's copied that down? If they're copying it down? Okay. Let's just start with completing the square. All right, let's do it. Let's do this. Let's do this. Might give you guys this for homework. So what I'm going to do is I'll just come back to it. I'll extract it. I'll extract what we need. What am I doing? Okay. So substitution looks like we're good. Our algebraic substitution looks like we're finding it pretty comfortable. The next skill to learn is completing the square, which I think for most of us we're pretty good at it by now, especially the way I've set it to you guys to learn it. So x squared minus 6x plus 13. We've got to complete the square. So whose turn is it now? Ben.
Hello.
So this would be a completing the square question. Can you tell that this is not a U substitution? The hardest thing, actually, you're going to find in integration, once you finish 4 unit, is being able to identify the different skills required for each one. Like to know, okay, is this one going to be a completing the square? Is this going to be a U substitution, trig substitution, T formula substitution, blah, 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 right? That's going to be the hardest thing. Now, can you realize that if you decided to say, oh, Sam, can I choose U as x squared minus 6x plus 13, would this work? Well, I'll just be like, well, okay, differentiate. That gets you this. Do you have a x term on the top?
No.
No, so then therefore a U substitution would absolutely fail. It would just won't work. That's pretty much what you're going to do initially once we complete the topic to be able to know, okay, is this going to be a U substitution, or in this case, we're going to start with completing the square. Is this going to be a completing the square? You'll know this is completing the square. It looks so close to what you've been doing with your factorizing and trinomials and everything like that. Completing the square. All right, here we go. Integral dx on. Do you know the answer to this straight away when you've completed it, or do you want to do it on the side?
Oh, let's just do it on the side.
All right, so x squared minus 6x constants should always be on the other side. Cool? Make it equal to 0 for now. Here we go. Bracket squared equals?
X minus 3.
X minus 3. You halve it. Constants on the other side plus
9.
9. And then, of course, you are not solving. Yes. You are factorizing. So the answer we're looking for is?
Plus 4.
Plus 4, right? You bring your minus 4 over to the left-hand side again. So now you're here. X minus 3 squared plus 4. Does this look familiar at all? X squared plus a squared?
Oh.
Inverse tan.
Yeah.
So this one's an inverse tan. Do you remember? And this is monic. It's power of 1.
Yeah.
Right, it's coefficient of 1. So the answer is 1 on A,
which is 2.
Inverse tan.
And isn't it f of x on A?
Yes,
that right?
x on A. I said x. It's probably better to use the x on.
Okay.
X minus 3 on
2
plus C. Great. And I mean, just from you guys realizing this question right now that became an inverse tan, you can see why 4-unit students obviously perform better than 3-unit students as well, because by the time you get a question like this in a 3-unit exam, it just looks really easy to you guys because you've already been doing a lot of 4-unit integration with all of these cases that involve a hidden inverse tan, and you got to realize it's an inverse tan and so on.
Wow.
That's when you guys will have an advantage over your 3-unit students. Okay. Next. Greg, you're going to do the next one. Any questions about that?
No.
No. All right. Let's do this one. Next one. dx 5 plus 4x minus x squared. 5 plus 4x. Most of the time, just so you know, of completing the square, it's going to be either inverse sine or inverse tan. And the reason why, because completing the square will always look like this.
Yep.
And if it's always going to look like this, then therefore will always be an inverse tan. Or if it's inside the square root, it's always going to be an inverse sine or inverse cos. So pretty much all, like 99% of completing the square questions are going to end up becoming inverse trig.
Yep.
Cool. All right, we'll do it on the side again. It's just better. Equals 0. What are you going to move? I would personally, because it's negative squared. Yeah, I would do it like this. I would move these two over to the right-hand side. Keep my constants on this side. Okay, so 5 equals, and then bracket,
x minus 2 squared.
and
Bring it over.
what are you going to add here?
You would add 4.
4, which
Yeah.
becomes 9. And then instead of bringing the 9 over, because
You
then
bring the other side.
you're going to bring this guy over.
Yep.
And then technically, you don't need equals 0. All right, good job. Dx on. Okay. This is inverse sine.
Yep.
What? Do you know it?
Inverse sine, so that's just x on a, so that would be x minus 2 over 3.
Good job. This is worth 2 marks now in extension 2.
Yeah.
Good job. Anybody, any questions? Any questions on how we've completed the square? Okay. Not yet. Next one, please. These ones look easy. Let's do dx on square root. Dx on. Okay, you ready?
Yep.
All right, here we go. Again, we've got to complete the square. Well, look, again, the only 2 skills you know so far is, I guess, substitution or completing the square now. So you got to ask yourself, would this be a substitution question? Well, again, if you had let it become this, you had differentiated, you would have ended up with something like this. And you can see that nothing like that can exist on the top.
Yeah.
So if not a U substitution, it would be a completing the square question. X minus x squared equals to 0. And then, what do you want to do? Well, this is a little bit annoying having the minus x squared there, right?
So you can't you just times by -1?
Fine. Yeah. I'd like to avoid it, but if that's the way you've been doing it, that's fine. Negative, and then go tell me.
X minus 2 squared equals 2 squared.
It doesn't. So if you're going to put a negative there, then this has to become a -4.
Okay.
That's the problem, because this is +4, but then when you expand it with this negative, it's going to become -4. And then what will happen when you bring it over, it becomes 4 minus. And then you can see that's true, because look, expand this, that becomes +4, right? And then you're going to have 4 minus +4, which is meant to be 0, because you don't have any constant terms here. Okay. And can you realize what this is?
Sine.
Say it again.
Inverse sine.
Yep. So inverse sine, what's your answer?
X minus 2 on 2 plus C.
Greg, I'm just going to mute you.
Oh, that's my bad.
Oh, good. I think I'm pretty happy with that. Yeah, let's look at some more of these trig ones. I think I'm pretty happy with completing the square. Looks like you guys picked that up pretty quickly. So I'll send you that booklet or that particular sheet with the answers. But some of these trigs that we haven't done. So let's see what's in the formula sheet. In the formula sheet for differentiation, we've got sine, which becomes cos, which becomes negative sine, but we're doing it the SC way. Tan, which becomes sec squared, and that's it. That's unfortunate. What about these last ones? Ugh, there's more memorizing. All right. So we've got integral of 10. Let's on this side, just so you know, you've got the integral of sine, you've got the integral of cos, you've got the integral of sec squared, but you can see you don't have the integral of tan. And of course, you only have the derivative of tan, which is what I was saying before. So let's start with the first one, which was integral of sine theta. Let's write these SC, SC, SC. Okay, whose turn is it now? Mithuli, integral of sine theta. Down, differentiation going up is integration. So what's the derivative of sine theta?
Cos theta?
Yep, no, it's not exactly cos. Look at it. Integral of sine.
Oh, negative cos.
Negative cos theta plus c. Good job. Easy one. Novak, next one. Integral of cos theta becomes?
Integral of cos theta becomes sine theta.
That's it. Plus c. Okay. Queenie, next one. Tan theta. Okay. Queenie, you there?
Yeah.
The thing is, we don't have the integral of tan theta. Right? We've only got the integral of sine, cos, and then sec squared. So for tan theta, we've got to be a little bit more unique. Tan theta. Okay, what do you know tan theta equals to from our Thursday classes? So tan theta equals?
Cos on sine.
Other way around.
Oh, sine on cos.
Sine theta on cos theta, right? Now that's great, but you got to also now know this one here. Log. What does a log say? Log says if you've got a function at the bottom and you've got its derivative out on the top, then the answer is actually log of the bottom. Okay, well, what's the derivative of cos? Isn't the derivative of cos there? Isn't that negative sine? Well, technically, isn't it just sine? Like, isn't the derivative of cos at least sine? So the answer to this is actually a log. But because the derivative of cos is negative sine, the answer will be negative log of the bottom, which is cos theta plus c. Do you get how that's working, Queenie? Queenie, do you get that, how that works? I can't hear you. Oh, am I on mute? I'm not on mute. I'm cutting out. You're cutting out. It might be anybody else. Am I cutting out to anybody else?
You're fine.
No, you're good for me.
Yeah, Queenie, might be your internet then. Just let me know when you're back if it's working better for you. What about to the others? Did you guys get what I just said there with tan theta is sine on cos? And then the only way you're going to be able to integrate that is to realize that the derivative of cos is sine. It's negative sine, which we can fix. There it is. But at least it's sine, which means this becomes a log, just like the same way as this. Derivative of x is 1, so the answer is log of x. So logs are going to be the hardest ones to realize, but I mean, you'll get it wrong so many times, you'll just learn to always watch out for the denominator. If it's going to give you the derivative as the numerator, it's specifically going to become a log. Okay, if we don't have any questions, we'll move. You can memorize that. Cosec squared. Well, before we do cosec squared, we'll just do sec squared. sec squared became sec squared. The integral of sec squared becomes tan, so that's very easy. Integral of sec squared theta, it's just tan theta. Integral of cosec squared theta is negative cotan. Cotan is just cot, so negative cot theta plus c plus c. The way I personally memorize these, if I create this little acronym, I call it co-negative. Co-negative, co-negative, in other words. What that means is every time I see a co, it's negative of the original ones I've got. So observe something here. Watch this. You had sine and it was positive. Cosine became negative. Sec squared is tan. Cosec squared is negative cotan. So every time there's a co in front of it, so if there's sec squared, if you've got to put a co in front of it, then it's just going to be negative cotan. Co-negative. Okay? Negative cot is cosec squared. I get it from sec squared. Sec theta, tan theta. It's strange that it's not in your formula sheet, because if it's not in your formula sheet, that would mean it might not be in the syllabus anymore. So just give me 2 seconds and let me observe that. U12 extension 2. Terry Lee. No, still there. We still got to know it. Too bad. Even if it's not in the formula sheet. I thought so. So the integral of sec theta tan theta is just sec theta plus c. So the integral of sec tan is sec. That's one you've got to memorize yourself. So can someone tell me what the answer to cosec theta cot theta becomes? If sec theta tan theta becomes this, what's the answer to cosec cot? Rosemary?
Yeah.
Any idea? Think of that little trick I showed you here. So if it was inverse sine, we said if it was inverse sine, it became a positive number, whatever this was, and then if it's inverse cos, it became a negative.
Negative.
So therefore, sec squared was tan theta. If it was cosec squared, you put a co in front of it. You're going to make it a negative, put a co in front of it. So put co in front of tan becomes cotan, cot. So if I've got sec and tan becomes sec. If we put cos in front of them now, see cosec and cot, the answer becomes what?
Negative sec.
Negative, not sec, negative co.
Co.
Cosec. You got to put a negative, so co and the negative. Negative cosec theta. Because all you're doing from sec to get into cosec, you're just putting co in front of it. To get tan into a cot, you're putting co. It's cotan. This is just a shorter way of writing cotangent. So which is cot. So
Yeah.
by putting if you know the first one, then if you just go to do cos, you can just put a negative in front of it and put a co. So negative co.
Yeah.
Cool. Good job. Did I close the other one? Ugh. It's all right. Let me see. I don't know what's missing. Sine, cos, tan, sec squared. Okay. Of course. What's cot theta? Well, the integral of cot theta would be integral of cos theta on sine theta. Again, this becomes a log. Derivative of sine is cos. It's positive cos, so the answer is just log of sine theta plus c. Are we missing anything? Cosec squared, sec squared, tan, cot, sec theta, cot theta, cosec theta. No, I think that's it. Integral of sec theta plus. No, yeah, that's perfect. That actually is all of them. Okay. So now, partial fractions, not for us yet. It's going to be next. Expression by parts. There we go. All right. So here's pretty much what we just did. Integral of dx on 9 plus 4x squared. Factorize your 4 out. A quarter. 9 on 4 plus x squared, and then that becomes inverse tan. So 1 on a, inverse tan, x on a. 3 over 2 is the same as saying multiplying by 2 over 3. 4x squared minus 9, factorize the 4 out. Square root of 4 is 2, so it becomes half. Dx on x squared minus 9 over 4. Oh, that's out of the syllabus now. These log ones are out of the syllabus, so I gotta update that. Okay, I'll update that one. Let's move to one that is relevant for you guys, which would be this one here. 3x squared plus 2x plus 1. That's weird. They decided to do that. We could just do it by completing the square. So you would have x squared plus 2 on 3 plus a third equals 0. Bring a third over to the other side. So you're going to have x plus equals negative a third plus half of 2 over 3, which is 1 over 3. And then square on this side, 1 over 9. Bring it all to one side, that becomes negative 2 over 9, so x plus a third plus 2 over 9. And then, so realistically, you should have gone from this line, I'm guessing you would have skipped that, to this line. And then once you're at this line, you don't need to make it a U sub. I think you guys can all probably see it. That just becomes inverse tan of x on a. A is, by the way, root 2 on 3. So 1 on a, 1 on a, 1 on this becomes 3 on root 2, inverse tan, x plus a half, x plus a third, sorry. X plus a third, and then root 2 on 3. 1 on root 2 on 3, which is 3 on root 2. And then 3x plus 1, 3's will cancel out. Yep. I'll probably update this and send this to you guys because those log ones are not in the syllabus anymore. I know that. And then we're going to do trig substitutions next week. Okay. Let me stop this. So what I'll